Okay, we want to get started. Welcome everybody to reInvent. My name's Chris Whittaker. I'm the development manager for AWS CloudFormation and AWS Elastic Beanstalk, both of those two services. Over in the corner over there, we have some other guys from the team, so if you have questions at the end. So we have Avinash. He's a dev manager. We have David. He's the developer from Elastic Beanstalk. We have Adam, who's a developer on CloudFormation. So at the end, if you want to come find us, come find us. So just to get started, so I'm going to assume nobody knows anything about CloudFormation. So this is going to be kind of an introduction session. We're going to walk through a few things. Just to kind of start off, as we talked to customers, what we found was there were a bunch of things that were consistent across various things as we talked to customers. So customers wanted to be able to create multiple environments, maybe a test environment, a pre-prod environment, and then a production environment, and make sure they were all the same, so that they had the same configuration, same security settings, things like that. We also had customers that wanted to take an application from one region, move it to another region. We also had customers that wanted to see all the configuration in one place. So they want to see all the security settings, all of the parameters for all of the resources that they have. And so that's kind of why we built CloudFormation. And so we'll walk through how CloudFormation helps with those things and how you can use CloudFormation to set up multiple stacks, multiple instances, different regions, things like that. So what are we going to do? So here's the kind of overview of what we're going to do in the presentation today. We're going to walk through what CloudFormation is as a service. And as we go through that, we'll look at some of the benefits that we have for CloudFormation. Why should you use CloudFormation? And then we'll look at how easy it is to use. Hopefully you'll see that as we walk through it. So what's CloudFormation? The intent of the service is really to make it easy to deploy sets of resources that you need for your application in AWS. So it's really about collecting all the resources you need together, building all of those things, and running the application. So AWS has kind of many building block services. So for example, EC2 for compute, S3 for storage, RDS for databases, various things like that. If you build an application, typically you need resources from each of these different services. So if you're building, say, a web service, you might need a load balancer. You might need some EC2 instances or an auto-scaling group. You might need security settings, a database, various things that you need for that application. So what CloudFormation lets you do is specify all of those things in what we call a template. So a template is just a fancy name for a text file. It's really just a JSON text file, and we'll look at one of those later. But what you do in that text file is specify all the resources that you need in order to run the application. So it's purely declarative. It's not a script. So you just list out the set of resources with the properties that you need for that particular application. You can also specify dependencies between resources. So for example, you might need the instances to come up after the load balancer. Getting some feedback. So you might need the instances to come up after the load balancer. You can specify those kinds of dependencies so that you can order the things as they come up. You can also specify data flows between resources. So for example, the RDS database, you might need to pass the connection string of that database to the instances that are actually going to use the database. So it gives you a way in the application, in the template, to specify all of those dependencies, all of those resources. So you're effectively building up the architectural diagram of your application inside the template. So that's really what CloudFormation is all about. So the diagram at the bottom there is you define a template, contains all of those resources. You then pass that template to CloudFormation. CloudFormation then takes care of calling all the other services on your behalf. So it creates all of those resources in your account, spins everything up in the order as necessary, flows all the data as appropriate, and then builds what we call a stack. So really there are two concepts that CloudFormation brings. First is the template, and then, so that's the specification, if you like. and then the stack, which is a running instance of the template. And you can create multiple stacks from the same template, and we'll see that kind of in action. Once you have a stack, over time, the application dependencies or the requirements on that application might change. So for example, you might need a bigger database, you might want to add a cache, you may want to change properties of alarms or some of the other resources in there. So CloudFormation lets you modify the template and resubmit that template to CloudFormation. So you can make changes to either the resources, you can add and remove resources from the template, resubmit that template. CloudFormation will then effectively do a diff between the template, the new template that you passed, and what's already running. Look at what the differences are, and try and create the minimal set of changes necessary to bring your stack up to the next template version, if you like. So it allows you to manage the application over its life cycle. So that's kind of...
Will CloudFormation also update existing running instances?
Yeah, so the question was, will CloudFormation update existing running instances? So you can make changes to properties on an instance and resubmit that template, and it will make changes to that instance. Now, some changes can be made dynamically. Some changes cannot. So for example, if you change the army, so I want to run a different version of some software, then we'll actually spin up a new instance and replace that instance in the stack.
So things like installing a new service, let's say a template didn't have Apache installed, now it does. Will it install Apache?
Yeah, so we'll actually walk through an example that looks like that. So the question was, if you don't have Apache installed and you want Apache installed, can you do that through a template? And yes, you can, and we'll kind of walk through that. So what is a template? How do you actually create template? How do you use it once you have it? So we'll look at a template in a minute, but the thing to look at is a template's really divided into multiple sections. So there's a resources section, and that resources section contains the list of all the resources that you need for the application. So security groups, EC2 instances, RDS databases, and so forth. So it lets you create all the resources that you need in that section, along with all the properties that you need for those resources. There's then a parameters section. So one of the things about CloudFormation templates is you can reuse a template to create multiple stacks from the same template. In some cases, you actually want different properties for different stacks. So for example, I might have a test stack and a production stack. In the test stack, I want, say, 2 instances, but in the production stack, I want 10 instances. So CloudFormation allows you to add parameters to a template that get passed into that template at stack creation time, so that you can modify at runtime what actually gets created in the template. And we'll see an example of that. There are cases where you actually want to have different property values depending on things in the template, or maybe the different region that you're running in, or some other environmental properties. So CloudFormation provides a section called mappings. So really a mapping is, think of it as a table. It's really a way to say, given this particular condition, I want to use this value for the property. So it's a way to do conditionals in the template. And we'll look at that in a second. The final section is really the output section. So when you build a stack, things are created dynamically. You might want to pass back data to the user of that template. So for example, if I'm creating a website, I probably want to pass back the URL of the newly created website, because it depends on what the resources were in the template that got created. And so the output section lets you specify things that get propagated back to the user, and they get shown in the console. And we'll see examples of that. There's a few other things there before we start to look at a template. So because you can create multiple stacks from a single template, we don't have the physical names of the resources in the template. So I can't say I want the RDS to be called, or the RDS database instance to be called foo. Because if I rerun that template multiple times, then I'm going to get collisions on the naming. So CloudFormation in the template, you specify logical names for the resources. That's really just a way to identify the resources in the template and then be able to reference them elsewhere in the template. When we create the stack from the template, we actually create real physical names based on that logical name, but they will be different for each stack that you create. So we effectively uniquify, if you like, the actual resource names based on the resource names in the template. Along with kind of all the resources that you can specify in the template, we give you a mechanism to augment the data in the template, and that's called metadata. And we'll look at a little example of actually using metadata. But really, the CloudFormation service itself doesn't really look at the metadata. It's just additional properties that you can specify on the different resources in the template, so that you can, say, tag it with things that if you have tooling on top of CloudFormation, you can use that to kind of specify things. For example, if you're building, say, a UI on top, maybe some of the metadata is the XY coordinate of the block on some diagram. So you can use it for whatever you want. There is a very specific use of metadata that CloudFormation itself uses, and we'll go into how it uses that, essentially to put files and packages and other software on the instance. The final one there's a bunch of functions that you can specify inside a template. So not only can you specify actual values for the properties, but we give you a bunch of functions so that you can reference other things from within the template, or you can get attributes. So for example, the availability zone of an instance that got created, I can use that as somewhere else in the template. So I might want to put the EBS volume and the EC2 instance in the same availability zone, but I don't actually want to specify an availability zone. So we give you functions to be able to take values that were created as a result of creating a resource and using those values in other resources. So that's kind of the basic overview of a template. So if we flip to kind of, let's find a template. Oops, I have a meeting request. So templates are JSON format. I'm actually using a plugin in Firefox to actually show this, mostly because it's easier for you guys to see the specific things we're talking about. But it's really, if you look at the entire template, it's a JSON file, and this is just a rendering of that using a Firefox plugin. So this template is actually a fairly simple template. It's a single EC2 instance with an elastic IP address and a security group. And it's running a PHP application. So we can look through the template and we can see all of those things. So we'll go through one by one. On this screen? Can we move that slightly across? Oh, we done it. So let's look at the parameters section. So parameters, like I say, parameters are there so that you can specify values at creation time of the template that are not hard-coded in the template. So the parameters section is essentially just a list of parameters. In this particular template, I just have one parameter, which is called instance type. So all parameters have a name, in this case, instance type. Parameters also have a description. So that's really just a text field. And that'll show up in the console when we come to actually run this template. You'll see where that actually shows up. But it's essentially there so that you can specify to the user of the template, what is this value, what do you expect from it. Parameters can have default values. So in this case, the instance type parameter is actually going to be the instance type that we use to create the EC2 instance. And we're defaulting that to T1 micro in this particular case. Along with kind of the defaults and the descriptions and the types, so actually we missed type out. So type just defines what kind of property we expect this to be. So in this case, it's a string. We also have numeric. Whoops, I really should get rid of my Outlook. So you can just specify different types. So we have string types, we have numeric types, and we have list types. Where they're interesting is for the constraints that you can apply to that particular parameter. So in this case, instance type has a set of predefined values that we can actually use. So in this case, allowed values specifies all the EC2 instance types that support 64-bit in this case. There are other types of constraints you can put on. So if this was a numeric parameter, you can say minimum value, maximum value. For strings, if it isn't a kind of a list of specific ones, you can say it can be between this length and this length. We allow you to do regexes, so if you have some regex that you want the parameter to conform to, you can also specify that. So it gives us a way to validate the input from the user in the console, so that the author of the template can make sure that the property values that were specified are actually the ones that are valid for this particular parameter. And then the last thing there, constraint description. That's actually the error string that the console will print out if the constraint is violated. So in this case, it must be a valid 64-bit EC2 instance type if you don't type one of those things in. So that's kind of the parameters section. You can have a bunch of parameters in there. This just has one.
Can you parameterize the region?
Yes, so in fact, we'll see that in a second. So the question was, can you parameterize the region? So the mapping section, so EC2 instances obviously need an image ID in order to run. The image IDs are actually different depending on the regions. And so in this particular case, this application is running on a base Amazon Linux ARMY. So nothing special about the ARMY, it's just a base Amazon Linux ARMY. But the ARMY ID is different in each region. And so the mapping that I've defined here really is a mapping of which region to which ARMY ID. And so this is kind of a way to specify that. So for example, in the US East 1 region, the ARMY is the one that's specified there. And we'll see how you use these mappings inside the template to actually pick the right ARMY ID for the region. And you can specify other things in mappings. This is just an example of that. Then comes the resources section, and there's no particular order to these sections. They just happen to be in a reasonably logical order in this template. So in this template, we have 5 resources. So each resource is given a logical name. We talked a little bit about that before. So what you see in there is actually the logical names of each of the resources. So let's take a look at the first one, which is an instance security group, is what it's called. So each resource has a type. In this particular case, it's an EC2 security group type. And we'll see cases of other types. And then there's a property section for each of the resources. What we tried to do in CloudFormation is not define any new properties. So what you'll see here in the property sections for each of the resources, the properties that you would pass to the API calls of the different services. So we don't renaming things so that you don't have to learn anything new. The properties should be pretty obvious if you've used those services before. So we tried to keep it consistent. So for security group, we have group description. It's really just a text string. And then we have an ingress rule. This is like I said, it's a web service, so we're opening port 80 on the security group. And we just define in the ingress rule there for that. We then have an elastic IP address. So we want to associate the IP address with the instance. So again, it has a type, in this case EC2 EIP. And then an instance ID. Now, we don't know what the instance ID is going to be because the instance is going to be created by the template. And so what we can use is a ref function. So that's really a reference to something else in the template. So we can ref the EC2 instance, which if you look at the other resources, there's an EC2 instance resource in the template. So you use the name of the EC2 instance in the reference, and that'll actually return the instance ID of the instance that was created. So you can reference the physical ID of any of the resources in the template using the ref function. So that's how you do that. We then have an EC2 instance. So again, it has a type, EC2 Instance ID, EC2 Instance, and a bunch of properties. Now in this case, we're associating the security group that we created in the template as the property for security group. And again, that's a reference, because we didn't create the security group ahead of time. It's created in the template. So we reference the instance security group resource that was created. And then we have image ID. So this is where we pick from the table that we had in the mappings. So we have a function findInMap, which takes the map name, which is what the mapping was defined as before, AWS region to Army. That's what we called the table. And then what we're looking for is the Army in there based on the region. Now, to specify the region, we give you what we call a pseudo parameter. In this case, we're using AWS : region. That is set up by CloudFormation as the region identifier for wherever this template was run. So you're effectively using the region that the template was running to pick the Army ID from the list that we had. So that's kind of how you reference the region in the template. There are a few other kind of pseudo parameters that we have. So the stack name, if you want to put the stack name in there somewhere, and there's a few others. The next piece that this template actually does is we're just using the base Amazon Linux Army to fire up this instance. We actually want to run a PHP application on it, so we actually need to download and create the application on the instance. The way CloudFormation does that is there's really three pieces to it. There's a set of helper functions, if you like, that run on the instance themselves. That's the functions that run on the instance, pull down the files, the packages, whatever it is you need to actually run on the instance, because that obviously has to run on the instance as it starts up. Those functions are actually installed by default on Amazon Linux, as well as on the Windows armies that we have. We have packages that you can download onto many of the other Linux distributions. So you can use the same kind of functionality across any particular instance type, any OS type that you might use. So that's kind of the first part, is the functions that actually run on the instance, and we'll look at that in a second. The second part is kind of the metadata definition. So we talked a little bit about metadata. CloudFormation, the service itself, doesn't actually look at that metadata. But there is a special case of metadata. So there's a metadata section here in the template. And we have a well-defined name called AWS CloudFormation init. That's the name of this section of metadata. The on-host functions that we just talked about use this section to actually decide what to download and what to put on the instance. So you can define different configurations. In this case, there's just one configuration. But in that configuration, you can define things like packages, files, which services to start, zip files to pull down, various things like that. So in this particular case, what we're actually going to install on an instance is we're going to install Apache and PHP from the Yum repo. So that's how we define that in there. So it's really, when this instance starts up, pull HTTPD and PHP from the Yum repo and install them locally. We then have a section called sources. And in this particular case, sources is the location of a zip file that we want to pull down and unpack. In this case, it happens to be the application. So it's a sample application, really simple PHP app. And the sources definition is what to pull and where to put it. So we're putting that zip file into var www HTML. So that's kind of how you specify how to pull down a zip file, unpack it on the instance, and let it execute. Obviously, go ahead.
Just because you mentioned Yum.
Yep.
Do you guys support custom Yum repos?
You can, if you specify in a, so the question was, do we support custom Yum repos? If you set up the Yum repo so that it can be pulled locally from the instance, then we can pull it from there. We get the sources section. So once we have all of this stuff down on the instance, we actually need to make sure Apache is actually running. So the services section lets us start up any of the services that we need on the instance. In this case, we're starting up the Apache daemon, making sure it's enabled, making sure it's going to run if the instance reboots. So it gives you a way to download packages and files, and we'll look at an example in a little later of how to actually embed the actual content in here. In this particular case, we're just referencing a zip file that happens to be on S3, but you can actually put the content in here too if you wanted. So that's kind of the second piece that you need in order to download the software onto the instance. So we got the CloudFormation helper scripts on the instance. We got the definition of what we want to pull in the actual template. Yeah, so the question was, can you run your own scripts? There's actually so if we just open that a second. So along with packages, sources, services, there's also a commands section where you can run arbitrary commands on the instance as well. And some of those commands may well be from batch files or whatever that you actually downloaded as part of this. So that's the third section. So the third section is user data. So we need to run the CloudFormation helper scripts when this instance starts. Ubuntu, Amazon Linux, and the Windows Army actually allow you to put a script into user data. User data, for those that don't know, it's a property that you pass to EC2 instances where that data is just passed to the instance and available on the instance. So it can be arbitrary content. Amazon Linux, Ubuntu, and Windows actually let you put a script in there. So in this particular case, what I've done is we've put the script, and it's not particularly readable in this format, but we put a script in there, which is actually to fire up the on-host helper functions for CloudFormation, pull down the packages and files, and deploy those files. And so if we look at this particular script, it's a base 64 encoded script, but that's just because EC2's user data requires it to be base 64 encoded. And it's just a very simple batch file. First off, it does a yum update just to make sure we have the latest version of the CloudFormation helper scripts. They're actually installed by default, but with this particular one, just make sure we have the most up-to-date version. And then it runs the CFN init helper script. So that's really the helper script that pulls down all of those files and packages. And the way it does that is you specify where you want that metadata to come from. So you can attach that metadata anywhere. And CFN init, you specify the stack that it came from. So in this case, it comes from the same stack that we're building. And that's what the ref to AWS stack name does. So that's like the region function. It's another of those pseudo parameters. And you also specify the resource that you want to get that metadata from. So in this case, we attach the metadata to the EC2 instance itself. So you'll see there that, no good me pointing up my screen, I guess. So you'll see here that the resource that we're using is the EC2 instance. So that's just a reference to the name of the resource in the template. And then we give it a region. We need to know where that stack is created. And so that's really all you need to do to pull down all those files and packages and install them. So it's a pretty simple call. It goes out, fetches the metadata from CloudFormation, does whatever the metadata specifies to pull down those packages. The last command there, CFN signal. So that's another of the CloudFormation helper functions. In this particular case, what we actually want to do is make sure that the stack doesn't create completely until the application's installed. And so we have, I'll just come down a little bit to a couple more resources. So we have this notion of a wait condition. So you can think of a wait condition just as a semaphore. It's really just something that gets created but doesn't get completely created until it's signaled from somewhere. I can try. That work? Yeah, there you go. So we have a wait condition. That's really just a semaphore that needs to be signaled from somewhere in order to be created. So the very last command in the user data script that we had is a signal, and it signals the wait condition that we had. So essentially what's going to happen is we're going to call cf_init, download all the software onto the box, and then signal as soon as that's created. So now we know the application itself is installed and running, and so then the wait condition can be complete once the signal happens. So it's really a way to stop the stack being created completely until the application's installed in this particular case. So the output section in this particular template, we're passing back a bunch of things to the user of this template. So the instance ID, each output has a name, just like all the other properties in the template. And then you can specify a description. What is it that this output actually represents? In this case, it's the instance ID of the newly created instance. And we actually wanted to get the value of that, so we reference the EC2 instance that we created in the template in order to get that value back to the user. So that's kind of the instance ID. In the EC2 instance creation, we didn't specify an availability zone, so EC2 will pick one. So in this particular case, we're actually outputting which availability zone this instance got created in as one of the outputs. And to get that, so that's a runtime attribute of the EC2 instance. So ref gets you the physical ID, but we need all the properties of it. And so we have another function called getAt. And what that does is, given a resource, in this case EC2 instance, and a property, in this case availability zone, returns back that property of the instance that was created. So it lets you kind of get the runtime properties of the instance, in this case, to pass back to the user. You can also use getAt anywhere else. So if you wanted that availability zone to be attached to the EBS volume, you can also use getAt to fill in properties of other resources. And then finally, the last output that we have here is the URL. We want to pass back the URL of the website we just created. And so that's a concatenation of multiple things. So we want the HTTP//, but we also want the IP address of the EIP that we created. So we have a function called join, which allows you to concatenate strings. And so in this case, we're concatenating the constant HTTP:// with the EIP address that we got back from the instance, from the EIP. So now we have the URL of the newly created website. So the question was, why does the concatenation start with the empty string? So the join function allows you to specify the separator between the strings. In this case, I didn't particularly want a separator, so it's empty string. But you could put anything in there, and it will be added between each of the other sections of the join. So that's kind of the template. It's a pretty simple template. Creates 3 resources and a wait condition. Can you make a web service call from the template was the question. So no, it's purely declarative, so everything has to be specified in the template as declarations as opposed to scripts. So it's not run as such. Yeah?
For getting the source, is it S3 only, or you can get it from EBS also?
Yeah, you can get so the question was, do you have to get the content from S3? You can get it from any location. It's purely as long as it's a well-defined URL. Could be file colon.
And then when you're done creating it, you get the output as the IP. Then tie that in Route 53.
Sorry, can you say that again?
Can you tie that into Route 53? Like if you get
Yes. So the question was, given the IP address, can we tie that into Route 53? So CloudFormation supports most of the resources that AWS has, including Route 53. So you can create Route 53 A records, CNAME records, whatever inside here, and then associate the EIP address using the ref function with that name. Yeah?
in the case where you need to deploy some updated resources, is it possible to have just an update really what's happening with that?
Sorry, say that again.
Sorry, if you have, say, a software update,
Mm-hmm.
you want to update to the package, you didn't want to go through the process of redeploying the entire stack.
Mm-hmm.
Is it possible to do that as well, or like a more powerful?
Sure. So the question was, if you're just updating the software on the instance, can you do that without doing a stack update, essentially, or without updating any of the resources? So just using CloudFormation itself, you can change the metadata that contains the packages and do a stack update. We'll only update the metadata. There are other functions that you can use on the instance to look for changes to metadata. When that metadata changes, it will update the software on the stack. You're not actually updating any of the resources other than the metadata. So that's kind of the template. So let's actually walk through how you actually use that template. So this is the CloudFormation Console. It's one of the consoles for AWS. So we have a create stack here. So really it's just a case of creating a stack by hitting create stack. You give it a stack name. And you can actually pick templates from multiple places. So we have a whole bunch of sample templates that are visible in the console directly. So things like Drupal, Redmine, WordPress, various things. We'll talk about some of the sample templates later. So you can directly get to those. You can upload a template file from local disk, which is where I'll get it from, or you can provide a template URL. Now, right now, the only template URLs that we support are S3 URLs, and the template has to be in the same region as the template as the stack that you're creating. So that's a restriction on that one. So we'll pull a template file from here. So this is the template we were just looking at. So the second page is the parameters page, and this is generated from what the content of the template. So in this case, remember we only had one parameter instance type, and the default value is filled in for you. You can change that, so we can change that to M1 small if we want to. You can then tag stacks. So we allow you to add tags to stacks. There's a couple of things there. One is those tags will be propagated to all of the resources that support tags. So EC2 instances, EBS volumes, VPC, all of those things. Those tags will get propagated. You can use those then for cost allocation purposes. So you can use Amazon cost allocation by tagging. So it means that you can use, if you spin up an application using CloudFormation with tags, you can then see over time how much that's actually going to cost you. So we'll put a tag in here.
Can you add tags to the template?
You can put tags on resources in the template. So the question was, can you put tags in the template? So any resources that support tagging, you can also, as one of the properties, support tags already in there. And then you kind of get a summary page of what is it we're about to do. So we're about to create this stack. There's a link to the cost calculator here. So that's the AWS cost calculator. So it fills in all of those properties from the template that you specified. And it will give you an idea of what is it going to cost to run this template. And we'll just hit continue. And that's really it. So now the stack is creating progress. And ultimately all of those resources will get spun up.
Can you get the source code for the sample CloudFormation?
Yes, and so I'll walk through this, where to get that from. So reInvent Demo 1 is a stack that I created earlier, and it's from the same template, so it's exactly the same template we were just looking at. That's already create complete. In the bottom section here, you can see various things that we give you back about this stack and the template. So in the description tab, we really give you what is it that this stack is. So it gives you the description that was in the template, which is down here. Tells you when it was created, what its current status is, and then a stack ID, which is, you can use that for various things. If you use an API calls, for example, you can pass the stack ID to that, and the stack name. So that's really just kind of an overview of this particular stack. You can see the resources that were actually created. So in this tab, we give you the mapping that we created. So in the template, we had logical IDs. We actually created physical resources behind those. So each of these logical IDs is mapped to a physical ID. So in this case, the security group that was created from instance security group in the template is actually this physical ID. And then there's various other things. You can see the original template. You can see parameters that were passed in. You can see the tags that were passed in. So it's really just, here's all the things that you did in order to create this stack. Just kind of, yep.
So if you go back to the events tab, it shows basically what it's currently doing and when it's done.
Mm-hmm.
It doesn't, at least I haven't found a place where it can show me what's left to do.
That's right.
I found that to be important because one of the nice things that CloudFormation
Mm-hmm.
provides is the ability to auto-resolve dependencies and make sure
Mm-hmm.
all that. So if I leave that over to the CloudFormation, and I don't really know exactly what's left to do.
That's good feedback, actually. So the feedback was, it doesn't so the events tab gets populated as things happen, but it doesn't tell you what's left to do. So that's good feedback.
How do you resolve issues like basically debug?
Mm-hmm. So the question was, how do you debug stacks? So right now, the only way to do that is to actually create it, which is kind of an iterative process. Yeah, so if the stack fails to create, everything gets rolled back. So we'll delete everything that was created. Yep. So flipping on. So what can I include in the template? So we support basically a broad range of the AWS services. The list too long to mention, but it's all in the documentation. CloudFormation itself has a few resources that we can create, so weight condition and metadata we've looked at. Custom resource we'll talk about shortly. The other thing to note is Elastic Beanstalk, the other service that is kind of in the same space, actually uses CloudFormation to create Elastic Beanstalk environments. There's a talk on Elastic Beanstalk later on today, if folks are interested. I have the session at the end. So how do I change my stack? So the template's just a text file. You can make changes to that. Go ahead.
Just one quick question. Can auto-scale groups be a scaling event for all CloudFormation templates?
So the question was, can auto-scaling groups via the policy and the trigger cause CloudFormation templates to get executed, I think is it. Not today, although it's certainly something interesting. So how do I change my stack? So the application requirements can change over time. I may need to add a cache. I may need to add additional resources, change properties. So really, you just edit the template. It's just a text file. You can version control that text file along with all the other application artifacts that you have. So you can effectively version control the infrastructure by version controlling the templates. You can update properties of existing resources. So if you need to change existing properties, you can do that. If you need to add resources, you can do that. If you need to remove resources, you can do that. You can change the metadata. We talked a little bit about that. So you can update the stack itself. So essentially, you just give us the template back. We'll do a diff and make the changes. Yeah, in fact, so the question was if I update the security group. So there were a bunch of questions, so we're running a little bit behind, but there's so I actually have a template which has some diffs from the original template. So in this particular case, in the original template, we didn't add a key pair to the instance, so I can't SSH to the instance. So now I want to be able to SSH to the instance. I need to actually change the instance. I need to change the security group so I can open up the SSH port. So in this particular case, oops, wrong one. Try that one. So in this particular case, what I've done is added a parameter key name, which is really just to give me a separate key name. And then in the resources section, I've modified the security group to also open port 22, so that I can SSH to the box. And in the instance, I've also specified the key name in the instance. So if I take my original stack and apply this template to it, it will make those changes. In this case, you can't change the instance on the fly to add a key name. So we'll create another instance with the key name in it, and then we'll associate that with the EIP. So in this particular case, we're actually tearing down the existing instance and bringing up another instance. But that's just because the key name can't be changed on the fly. Sorry, can you? I didn't hear that.
So if I have some sensitive data on my live instance
Mm-hmm.
on a non-ES volume, and if I make this kind of a change, I can do something.
Yeah. So if you have, so the question was if you have data on the volume, data on the instance which is transient, if you like. So in other words, it's on the boot disk of the volume of that instance, you'll lose that data. We're really going to replace it.
Can an instance detect that an update is coming to it and it say, okay, hold on, let me do clean up,
Mm-hmm.
or save sensitive data to some system?
So the question was, can an instance detect an update's going to happen? So not right now, although it is something we're looking at, which is how do you get the instance to participate in the stack update process? So that's something we're looking at. So getting started with templates, there's a bunch of different places, but essentially we have a template library. I'll just flip quickly to that. So there's a template library that contains a whole bunch of different kinds of templates. So it contains end-to-end templates, so we have a bunch of Windows samples like SharePoint. We have a whole bunch of recently added ones. There's open source applications, so this is kind of where you get the templates which are from the drop-down in the console. So that's essentially this set of templates here. Yep.
Talk a little bit about how would you integrate this with auto-scaling?
Sure. So the question was, how do you integrate with auto-scaling? So in a template, rather than an EC2 instance, I can create an auto-scaling group and then set up whatever policies and triggers I want on that particular auto-scaling group. So just like we added an EC2 instance here, some of these applications actually use an auto-scaling group instead.
Could you use these templates to provision an instance and aid in the baking of an image to put out on multiple?
Mm-hmm. Yeah, so the question was, can you use the templates to create essentially an image that you can then use elsewhere? So yes, you can create a template that downloads all the software, puts it on the box, and then manually create the image from that instance. We don't give you a mechanism inside CloudFormation to say, make this into an army right now. It's something we're looking at. So that's the template library. If you go to the CloudFormation homepage, there's a link on the left-hand side to take you to the template library. And that's actually a good place to start if you're building a template, is pick one from the template library and just modify it to whatever you need for your application. So what if you have an application already running and you actually want to create a template from it? So we provide a tool called CloudFormer. And that's really, it's kind of an appliance that you spin up in your account. So it's an instance, it's running software. And it runs through your account, all the resources in your account, and lets you select which resources you want to include in the template. And then it allows you to customize the names that get put into the template or add outputs, things like that. And so you can kind of use it as a starting point for creating a template from an existing application. What it does, though, is it fills in all the properties. So, for example, if there was an EC2 instance, the template that got created through CloudFormer would actually include the availability zone in it because it's one of the properties. So it's really a starting point. So you can use that as a base and then either take things out or abstract things out, whatever you want to do with that. So that's kind of how you would create a template from an existing running application. What if you got non-AWS resources? So CloudFormation, we've talked a lot about kind of all the AWS resources that you can put in a template. So a couple of weeks ago, we launched a new feature that we call user-defined or custom resources. So you can now specify anything really in a template. And the way that works is CloudFormation obviously doesn't know how to interact with an arbitrary resource. We obviously do the work to do AWS resources. But if you have, say, I don't know, pick one, Pingdom, for example. If you want to include a Pingdom alarm as part of your stack, CloudFormation doesn't know how to talk to Pingdom. But we have the notion of a bridge, which is a piece of software that you write that interacts with CloudFormation through essentially an SNS topic, allows you to get stack creation, stack update, stack delete notifications. You get those notifications, and then you can call whatever service you want on the back end of that. So it's kind of a bridge to be able to add anything you want into the template, and then create those resources, even if they're not AWS resources. Just as a quick kind of view of what that actually looks like, this is actually a Pingdom example. So the resources look the same logically. So each one has a type. In this case, custom resources, the type that we use for resources that we don't know about. And then the rest of the properties are essentially up to you. It depends what you need for that particular resource. So you can specify anything in there that resource needs. The only property that you have to specify is the property called service token, which is essentially an SNS topic that whatever your application is listening to gets sent those messages. So you'll get a stack creation message that says, I want to create this resource as part of this stack. Or you get an update request that says, I want to change these properties of that custom resource. Or when you delete the stack, you'll get a delete message. So it's really, where do we send the messages? And we'll package up all the properties that are in the template and send them to you during those events. So you can do whatever you want with those particular things. So, sorry, say that again?
Is that a reasonable way to tell instance what another public?
You could certainly use it for that. I don't, we haven't got examples of that. So the question was, is that a good way to use to get the instance itself to be a participant in the transaction, in the stack creation phases? We could certainly use it for that. So if you only remember 3 things from the presentation, I guess, so templates are reusable. You can create the stack, you can create multiple stacks in a single region, you can create stacks across regions, all from the same template. Now that we have custom resources, you can extend the set of resources you want to cover whatever application requirements you have. And we support the full application lifecycle, so you can create, update, delete. You can make changes over time depending on how the application changes. So I guess call to action. So try out CloudFormation if you haven't already tried it out. Take one of the sample templates, modify it, customize it for your own applications. Or use CloudFormer to create a template from your existing application. And then try to update stacks, see what happens. Sorry, go ahead. Okay, yeah. So the question was, what happens if an update fails, I guess? So if you do a stack update and the stack fails, then we'll roll back any changes. That's why we, in some cases, create new things. We leave the old things around just in case it rolls back to put it back in. So we'll try and recover from an update if it fails. So here's some related content. Introduction to Beanstalks later this afternoon. There's a few other presentations there that include CloudFormation. If you have any questions, I'll be in the developer lounge later, along with the rest of the team. so come find us.
Is there any way to lock specific resources to prevent, say, updating your CloudFormation template and updating certain parameters that not allow them to
So the question was, is there any way to lock down resources so that you can't accidentally break them, I guess? So not today, but that's a good feature request. And then finally, since this is the first reInvent, your feedback's, we're very happy to get your feedback. We'll do more sessions, and getting any feedback would be great. Thank you.